In this video, I'm just going to give you a quick review of everything that we've done with Unit 3, so that includes stuff from the College Board module, in addition to a couple things that we've done outside of it. So we're going to perform operations, so we're going to add, subtract, multiply, and divide, and then we're going to talk about the graphs again and bring those characteristics back in. So let's first start with this problem. If you go and look on Edmodo, I actually posted a PDF form of all of these problems actually, so you can just print that out and do the problems right on there instead of having to rewrite everything. I'm totally okay with that. So taking a look at the first one, you will see that we've got this minus sign in between our parentheses, which means we need to distribute our negative. Now the negative only goes to the stuff after the minus sign. So I'm keeping x squared as it is, negative 5x and plus 2, those all stay. But now the 3x squared becomes minus 3x squared, positive x becomes minus x, and a negative of a negative 1 becomes a positive 1. And then combine your like terms. So x squared minus 3x squared is a negative 2x squared. Negative 5x and a negative x is a negative 6x. And then a positive 2 and a positive 1 is plus 3, and that would be your final answer. So once you distribute that negative, you keep everything out of parentheses and you just combine your like terms. In the second problem, we're doing basically the same thing except it's just addition, so we get to get rid of the parentheses right off the bat. We really don't need the parentheses at all with addition. So now we're just going to combine our like terms. 7b squared and 4b squared gives you 11b squared. Then we get plus 6b because it doesn't have any like terms, and then negative 7 and negative 2 is a negative 9. All right, number 3, this time this is multiplication because there's no addition or subtraction sign in between the number and the parentheses, so we're just distributing. 3 times 2 is 6, x squared times x is x cubed, and then we have y. Then we have a minus. 3 times 3 is 9. X squared times x is x cubed, and then we have our y squared. And then, so that was that one, and then distribute to your last. We have a plus. 3 times 4 is 12. X squared times x squared is x to the 4th, and then we have y cubed. All right, and so remember that anytime you're doing like x squared times x, that is x, and then you add the exponents to give you x cubed, and the 1 coming from that exponent right there. All right, number 4, same thing, just multiplying. So negative 2 times negative 5 is positive 10. A squared times a is a cubed. And then we have b. And then c to the 4th times c squared is c to the 6th. And that is your answer. And then I guess I should probably come back here and show you that this is also your answer for this one. And the reason we didn't have anything to combine is because none of these are identical. So even though this one has an x cubed and this one also has an x cubed, they can't be subtracted because their y's are not the same. It's y squared here and just y here. So they have to be exactly identical for the variables so that you can combine them. Okay, number 5, same thing, just now we have some negative exponents. So what I'm going to do first is multiply the number, so we get negative 6. Then we have y to the negative second, so y to the negative second, let me go ahead and do this, times y to the second times y. Well, that just means we're taking y and taking negative 2 plus 1, which gives us y to the first power, so that's just y. Then we've got x cubed, x to the negative third, and we're multiplying that by x to the 4th. So that gives us x to the negative 3 plus 4, which is just x to the first power, so that's just x. So there's your answer. Okay, so that's one way to work with negative exponents. Now, a second way to work with negative exponents is having a negative exponent something like out here. So what happens, what you want to do first is, because this is negative, remember if you swap positions of numerator and denominator, then the negative will go away. So what I'm going to do is move 5h to the 5th to the top, and then 6g to the 5th over h to the 4th to the bottom. Now because I swapped positions, this 3 becomes a positive 3 exponent. And then I'm going to raise everything to the third power. So 5 cubed times h to the 5th cubed over 6 cubed times g to the 5th cubed times h to the 4th cubed. So what I get here then is 125, and h to the 5th raised to another power means you multiply the exponent, so h to the 15th, over 216, again multiply the exponent, so g to the 15th, and then h to the 12th. And then we simplify as much as we can by dealing with our h's. So we would get h to the 3rd up top, because that's where your highest exponent is, and g to the 15th on the bottom, and so this would be your final answer. So remember, when you're dividing, all you do is subtract your exponents and put it where your higher exponent is. All right, moving right along, number 7. So same idea, we're just dividing. So 12 divided by 2 is 6, and remember you always put it where your higher of your two numbers is. X to the 4th over x is x cubed, and it goes up top because that's where the higher exponent is. And then y squared over y to the 5th. 5 minus 2 is 3, but since y to the 5th is the bigger exponent in the bottom, y cubed goes in the bottom. And that would be your final answer for number 7. Okay, now number 8. What I'm going to actually have you do with this one is simplify each of these before you go ahead and do any multiplication. It's going to make things a lot easier on you. So let's simplify this first. So negative 20 over 30 is a negative 2 over 3. X to the 3rd over x to the 5th is x squared on the bottom. And then y to the 5th over y is y to the 4th on the top. So using those rules of the exponents. Multiplied by 10 over 5 is 2. 10 is the higher number, so that's where 2 goes. Now we have a negative exponent here. So what I want to do is work with positive exponents. So I'm going to move x to the bottom, and now the 4 becomes a positive. I'm also going to move y to the negative 2nd to the bottom, so it becomes positive. And we still have x to the 5th, and not x, sorry, but y to the 6th down here. So at this point, my whole first fraction is going to stay exactly the same, but the second one is going to have x to the 9th now and y to the 8th. And now we can actually multiply these. So we get a negative 4, and that's y to the 4th, so that's my whole numerator, and I'm just multiplying straight across, over 3 x to the 11th, y to the 8th. And then we just go one step further by simplifying our y's. And so 8 minus 4 is 4, bigger exponent on the bottom, so that's where it's going to move to. So 3x to the 11th, y to the 4th as your final answer. All right, number 9. Now notice how we're only dividing by one term here. So even though there's an x and a y, there's no plus, no minus. So I'm just going to split these up, 4xy squared over xy. Then I'm using the minus from the in between, 2xy over xy, and then plus 2x squared y over xy. And then simplify as much as you can. X over x is 1, so we get 4, and then y, higher is on top, so it goes on top, minus 2, x over x is 1, y over y is 1, so it's just minus 2. Then plus 2, the y over y is 1, and then x squared over x is just x. And there is your final answer. All right, now your absolute favorite, which is long division. So I'm going to go ahead and shift this up a little. So the first thing is to make sure that you have a spot for everything. So y cubed, y squared, y, and a constant. Perfect. We don't need to add anything. So y plus 2 on the outside, and underneath goes y cubed plus 11y squared minus 10y plus 6. So y times y squared is what's going to give you y cubed. So distribute that through, y cubed plus 2y squared. Now remember that you are subtracting, so change all of your signs so that this becomes a 0, and then you get 9y squared here, and drop down your minus 10y. Now go through that cycle again. So plus 9y, distribute that through, so 9y squared plus 18y minus, so remember then you change all of your signs so that these cancel out, leaving you with a negative 28y. Drop down your 6. And then your last cycle is to see that a negative 28 times y will give you a negative 28y here, and then minus 56. But remember, you are subtracting, so change all signs so that that becomes a 0 and this becomes a 62. And this would be your remainder because there's no variable here. So your final answer is y squared plus 9y minus 28 plus 62 over y plus 2. So that's your final answer there. So that was your long division. Now, in the next one, we're going to do synthetic division. So remember that this thing right here just means you're dividing. So all we're doing is g to the 4th minus 3g squared minus 18 divided by g minus 2. So since g minus 2 is the factor, that means a positive 2 is our 0. So that goes in our box here. So we need a g to the 4th, we need a g cubed, we need a g squared, a g, and then a constant. So we need a spot for everything, even if it isn't already here. So when we fill everything in, g to the 4th is a 1, because there's a 1 right there. G cubed is negative 3. Or I'm sorry, not g cubed. We don't have a g cubed, so that's 0. G squared is a negative 3. G we don't have, so that's 0, and our constant is a negative 18. And so this one is just a big spiral. So the first one always drops down. Take the 1, multiply it by the 2, and write that in your next open spot. Add those together to get 2. Take this 2, multiply it by your 2, write that in your next open spot. Add those together and write that there. Take this, multiply it by your 2, next open spot, add them, and then one last time. 2 times 2 is 4, and negative 18 plus 4 is a negative 14. And so since we started with g to the 4th, our answer starts with g cubed and works its way down through every term all the way to the remainder. So your final answer would be g cubed plus 2g squared plus g plus 2, but then we have our remainder of minus 14 over g minus 2. And that would be your final answer there. All right, so one more problem dealing with graphs and how to graph these things based on its factored version. So the first thing is its degree. So the degree is basically how many x's are there. So there's 1 here, this one counts twice, there's 1 here, and then this one counts twice. So we have 1, 2, 3, 4, 5, 6. So the degree is 6. Okay, so all I did was add up the x's. How many are there in the problem? Now we have zeros in multiplicity. So zeros we get from the fact that we take every factor and set it equal to 0. So we take negative x and set it equal to 0, which is just 0. So x equals 0. Our second one is taking x minus 2 and setting it equal to 0 to give us x equals 2. But this one has a multiplicity, of 2 because of this square right here. So then our next 0 would be a negative 1, and our last 0 would be a positive 3, and that this one would also have a multiplicity of 2. So our x-intercepts are 0, positive 2, positive 3, and negative 1. So they're going to be kind of squished together. The degree is even, so the ends go in the same direction, so they're either both up or both down. So or, but because of this negative right here, that's what tells us they're going to both go down. So we need to have arrows down here and here. And then we also need to have a bounce at 2 and a bounce at 3. So we're going to cross through at negative 1, turn and come back to 0, turn and come back at 2, but bounce at 2, turn, and then bounce it 3, and then there you go. So that's what your graph looks like.